Alright guys, in this video I'm going to go through calculations involving buffer solutions. But before that I just wanted to show you guys a shortcut that will save us a lot of time. Okay, so here I've written down our Ka expression. Now I can rearrange this to find the H plus concentration, which we normally do anyway. And I get... Okay, now here, for concentration, I've got the concentration of HA divided by the concentration of A minus, right? Now I'm going to rewrite these as moles divided by volume, so that I get... Alright, so notice how in the numerator and the denominator, I've got total volume here. Now, these actually cancel each other out. So I can actually just rewrite this whole expression as... Okay, so here I've got an expression with just moles. And I think in your working out, this would be quicker. However, that is equal to this expression here, which is our standard expression, using concentration. And it's a bit longer, but you might find it more simpler. So if you prefer doing that, just do that. So I need to calculate the pH of a buffer made from 45 centimeters cubed of 0.1 moles per decimeter ethanoic acid and 50 centimeters cubed of 0.15 moles per decimeter of sodium ethanoate. And the Ka of ethanoic acid is 1.7 times 10 to the minus 5. Now, to get started with this, I'm going to write down the equations that happen within the buffer. Okay, so here are my two reactions. Now, I know that I've got 45 centimeters cubed of ethanoic acid and it's 0.1 moles per decimeter. So I can find the moles of that. And I get 4.5 times 10 to the minus 3. And my moles of sodium ethanoate is... Alright, so I know this is barely going to dissociate, right? So I know my moles of ethanoic acid is basically going to stay as 4.5 times 10 to the minus 3. However, my moles of sodium ethanoate, all of that's really going to dissociate into ethanoate ions. So I know now my moles of ethanoate ion is 7.5 times 10 to the minus 3. Now I can sub this into the Ka expression. Alright, so now I know that instead of subbing in the concentrations, I can just sub in the moles instead. And I get... Okay, so this here is the H plus concentration. And I just need to minus log it to get the pH, which is... Okay, so that's the answer for question 1. Now on to the next one. Okay, pause the video, try this yourself, and play it to see the working out. Okay, so here we've got a buffer solution that's made by adding 1.1 grams of sodium ethanoate into 100 centimeters cubed of 0.4 moles per decimeter of ethanoic acid. Calculate the pH. And once again, we're reminded that the Ka value is 1.7 times 10 to the minus 5. So firstly, I'm going to write down the Ka expression again, rearranged, and I get... Now I know I need to work out the concentration of ethanoate ions and ethanoic acid, or at least find their moles, which is probably going to be easier. Now I'm going to work out the moles of ethanoic acid, which is... Okay, so this is the moles of ethanoic acid I've got. And now I need to find the moles of sodium ethanoate. Alright, so I know the moles of sodium ethanoate is 0.0134. And since all of it dissociates, I know my moles of ethanoate ions is going to be 0.0134 as well. And I can just sub this into my expression here. So I get... I can just minus log this to get the pH, which is... Okay. Okay, here's another question for you guys to try. Pause the video, try it yourselves, and play to see the working out. Okay, so we've got 55 centimeters cubed of 0.5 moles per decimeter of ethanoic acid. And this is reacted with 25 centimeters cubed of 0.35 moles per decimeter of sodium hydroxide. Calculate the pH of the resulting buffer solution. Alright, so this is quite similar to our neutralization reactions that we did before. So firstly, like always, I'm just going to work out moles of everything that I've got. Alright, so I'm going to write down our ICF table again. Now I know that since this is the limiting reactant, all of it's going to react. So I'm left with 0 of that. And then I take away 8.75 times 10 to the minus 3 of both. Now, unlike the neutralization reaction we did before, we know now that the salt actually matters as well. So initially we have 0 moles of salt, and we add 8.75 times 10 to the minus 3. Okay, just like we do with a normal ice table. And now we know that we have 8.75 times 10 to the minus 3 moles of that. And now if I write down the Ka expression, I get... Okay, so here I know that this is my moles of ethanoic acid, and I can just sub that in. Okay, instead of concentration, if I use the moles of ethanoate ions as well. Now here I've got my moles of sodium ethanoate, and I know that's going to dissociate in a 1:1 molar ratio to form ethanoate ions. So then I can just sub that in as well. And then I can just minus log this to get the pH, which is 4.44. Alright, this last question is quite challenging. So pause the video, try yourselves, and play to see the working out. Okay, so we have 0.05 moles of sodium hydroxide added to 500 centimeters cubed of a buffer where the concentration of ethanoic acid is 0.2 moles per decimeter cubed and the concentration of sodium ethanoate is 0.25 moles per decimeter cubed. The K value is 1.7 times 10 to the minus 5. Calculate the pH of the buffer solution after the sodium hydroxide has been added. Okay, so here we have our buffer solution, and inside the buffer solution we have some moles of ethanoic acid and then sodium ethanoate. And once we add the sodium hydroxide, essentially that just reacts with the ethanoic acid and that forms more of this. Okay, now when the base and the acid react, we know that the moles of acid is going to decrease, and since it's forming sodium ethanoate, we know that the moles of sodium ethanoate is going to increase, and therefore the moles of ethanoate ions are going to increase. So essentially we just need to find the moles of ethanoic acid and sodium ethanoate once they've reacted. Okay, so firstly, to begin with, just like always, I'm going to find the moles of everything that I can find. Okay, so now we have our moles of acid and sodium ethanoate before the sodium hydroxide was added. Now, I'm going to draw an ICF table again, just to make everything more clear. Okay, so I'm going to fill out the initial moles, which are... Now, obviously, from looking at this, you can tell that the sodium hydroxide is the limiting reactant. So we're going to end up with 0 moles of that, which means we take away 0.005 for both of the reactants, and we add on 0.005 to the products, so that we get... Okay, now we have our final moles of acid, and we have the moles of sodium ethanoate, but we know for the Ka expression we need our moles of ethanoate ions. So we know this dissociates in a 1-to-1 ratio. So if we have this many moles of sodium ethanoate, we know we also have that many moles of ethanoate ions. So that's quite simple. And now we can just sub that all into the Ka expression, and we get... And now we can minus log this answer to get pH, which is 4.91.